Hey everybody, today we're going to start an important topic called factoring. Factoring is the opposite of distributing. When you distribute, you can think of it like you're multiplying a value into a group. So when we factor, that means we're going to be dividing a value out of a group. Let's look at some quick examples. So for instance, when I'm distributing, 2x distributed into 5x plus 4 means I multiply 5x by 2x and I multiply 4 by 2x. That gives me 10x squared plus 8x. I'd say there that I distributed 2x into 5x and 4. So if I need to go the other direction, I would call that factoring. If I wanted to factor 10x squared plus 8x, I would get 2x times 5x plus 4. You can see that's where we started over when we were distributing. I would say in this case that I factored 2x out of 10x squared and 8x. So we are going to be covering a handful of factoring strategies over the next week. The first one we are going to start with is the greatest common factor. You may remember the greatest common factor from middle school. It's the largest value that can be divided out of two or more values. So as an example, the greatest common factor between 9 and 6 would be 3. 3 multiplies into 6 and 9, and it's the biggest number that I can think of that multiplies into both. If you think about it, all of the numbers that multiply into 9, there's 1, 3, and 9. All the numbers that multiply into 6, well, 1, 2, 3, and 6. If I look at all of the numbers that multiply into each, the biggest factor, the biggest common factor, would be 3, just as a quick reminder. If I look at the greatest common factor between 15x to the 5th and 20x squared, I would call the greatest common factor here 5x squared. I know that 5 is the biggest number that multiplies into both 15 and 20, and both of these terms have at least a factor of x squared. So I would call that the greatest common factor of these two terms. So we wanted to determine the greatest common factor of each group of values. If you feel like you have a pretty good grasp of how to do this, go ahead and pause the video, try these problems, and then you can unpause to check yourself. Otherwise, let's get straight into it. So I want the greatest common factor of 12 and 8. So if I'm going to do that, I'll think about what are all the factors of 12? That's like thinking, what are all the numbers I can divide 12 by? Well, I could divide it by 1, or 2, or 3, or 4. Not 5, but 6. Wow, a lot of factors in 12. And 7, 8, 9, nope, but 12. Yeah, there's all the factors. What about 8? I could divide 8 by 1, or 2, or 4, or 8. That's all. Well, if I look at it now, between 12 and 8, the common factors, I've got 1 and 2 and 4. Those are all common. And out of all those common factors, the greatest common factor is 4, the largest of the common factors. Okay, well what about if you're dealing with variables? X to the 4th and x to the 7th, what's the greatest common factor of those? Well, in this case, I would look at the smallest exponents. That's shows me that out of both of these terms, they're both x terms, and the smallest exponent, well, I know that x to the 4 has 4 factors of x, and I know x to the 7 has at least 4 factors of x. So the greatest common factor would be just x to the 4th. I can divide both x to the 4th by x to the 4th, and I can divide x to the 7th by x to the 4th. I can factor that out of either one of them. All right, and then let's move on to something a little more complicated. What if you've got a mix of numbers and even different variables? Well, in that case, I'll start by looking at the numbers. 2 and 4, I can tell that something I could divide out of both of those would be 2. So I start by finding the greatest common factor of the number, and then I look at each variable individually. I look at the x and x squared. The lowest exponent would be 1, so I can factor out at least an x out of both of those. And then let's look at the y's. Well, there's 5 factors of y and 3 factors of y. Once again, the smallest exponent is 3, so I could factor out at least 3 factors of y. So 2x times y to the 3rd would be the greatest common factor there. The big idea as we get into factoring is that if it's possible, your first step is always going to be to look to see if there is a greatest common factor you can factor out of a polynomial. So let's practice factoring out greatest common factors. We're asked to factor the greatest common factor out of each of these expressions. So 4x squared plus 6x. If I look at the 4 and the 6, well, I could divide 4 by 4, or 2, or 1. 6 I could divide by 6, or 3, or 2, or 1. I can see that the greatest common factor there is 2. And then I've got x squared and x. Well, again, the smallest exponent would just be 1. I can factor out at least 1x out of both terms. So I'm going to write 2x, and I'm going to put that outside of a parenthesis. And then inside of the parentheses, I'm going to divide 4x squared and 6x for that greatest common denominator. I'll show you what I mean. 4x squared divided by 2x, well, 4 divided by 2 is 2, x squared divided by x, I subtract 1 from 2, that would just be x, and then 6x divided by 2x, well, 6 divided by 2 is 3, and x to the 1st divided by x to the 1st, that's just 1, so just that cancels that x out. So you can see I've gone backwards essentially. We usually multiply and distribute something like 2x into a group. But here I've taken a factor of 2x and I've factored it out of this group. Anytime you factor out the greatest common factor, you can double check and see if multiplying and distributing would bring you back to your original term. I'll just double check. 2x times 2x plus 2x times 3, well, that would be 4x squared plus 6x. It checks out. I did factor the right greatest common factor. Okay, well, let's move on. Here's 16y to the 8th and 20y to the 3rd. Let's start by factoring out the greatest common factor of the coefficients, the numbers in front, for 16 and 20, well, let's see. I look at 16. 16 could be divided by 1 or 2 or 4 or 8 or 16. And then 20, that's 1, 2, 5, 10, 20. Between, left a 4 out. I could divide this by 4 as well. And actually, yeah, it looks like 4 is the greatest common factor between the coefficients, 16 and 20. So I'm going to write that out, write that first. And then y to the 8th power and y to the 3rd power. I can see that 3 is the smallest exponent of all the y's in both terms. So that means I can factor out at least 3 factors of y. So now I'm going to divide 16y to the 8th by the greatest common factor, 4y to the 3rd. 16 divided by 4, that's 4. Y to the 8th divided by y to the 3rd. That would be like 8 minus 3. I can subtract the exponents. That would be y to the 5th. And then 20y to the 3rd divided by 4y to the 3rd. 20 divided by 4 is 5. Y to the 3rd divided by y to the 3rd. Those cancel out. That just becomes 1. 3 minus 3 is 0. Y to the 0 is 1. I'm done there. Again, I have the greatest common factor now factored out. If I wanted to check my work, I could multiply this back in just to check. Never hurts to check. That would be 4y to the 3rd times 4y to the 5th and 4y to the 3rd times 5. That gives me 16y to the 8th plus 20y to the 3rd. Once again, that checks out. Okay. Well, just have one more here. Here's 3 terms. Now in this case, I see there's a small coefficient 2. A greatest common factor can't have a number that's bigger than your smallest number. So I'll start there. I can see that 2 would divide, that I could divide 16 and 24 by 2. So I'm going to call 2 the greatest common factor. I can't have a number bigger than any one of the numbers. And then if I look at the x variables, there's 4 factors, 3 factors, 2 factors. Oh, that's the smallest number of factors. So x squared, I can factor out at least an x squared out of all 3 of these. So if I divide each of these terms by 2x squared, well, 2x to the 4th, 2 divided by 2 is 1. X to the 4th divided by x squared, 4 minus 2, I would have an exponent of 2. And then 16x to the 3rd, well, 16 divided by 2 is 8. X to the 3rd divided by x squared, I can cancel out 2 of those 3 factors, and I would be left with x. You could think of that as 3 minus 2 is x to the 1st power. And then 24x squared, 24 divided by 2 is 12. X squared divided by x squared, again, completely cancels out. Once more, I could multiply this to check, but that is the greatest common factor factored out of these 3 terms. Okay, so now I want you each to try yourselves. Here are 4 expressions. See if you can factor out the greatest common factor out of each. Once you're done, there is a key right below, so you can go ahead and check that. And good luck.